Reflections and rotations. So a reflection means that every point is the same distance from a central line. Reflections is probably one of the easiest things to do. So given these points, J, A, and R, what we're going to do is we're just going to practice reflecting these. So if you want to reflect on the x-axis, basically what we're going to do is if we have the x-axis, I'm just going to highlight the x-axis, and that's the line that we're going to reflect it. So if we plot the points, J, we've got 1, 4. So here's J, 3, 5. Here's A, and R, 2, 1. So here's our triangle. And what we're going to do is we are going to reflect it across the x-axis. So for example, if we start with J, and if we look, you can see that we are 1, 2, 3, 4 units away from the x-axis. So we want to be 1, 2, 3, 4 units away from the x-axis on this side as well. So this is where our point would be. This is where the new J would be. So R is 1 unit away. So then we would go 1 unit away here. So here's where our new point would be for R. And then for A, we're 1, 2, 3, 4, 5 units away. So then we've got 1, 2, 3, 4, 5 units away. So here's the new A. So there's our reflection across the x-axis. So reflection across the y-axis is going to be reflected, of course, across the y-axis. So if we sketch, if we get JAR back on our graph, so here's J, A, and R. Okay, so this time we're going horizontally. So J is 1 unit away, so we would go 1 unit away this way. So here's J prime. R is 1, 2 units away, so we'd go 1, 2 units away this way. A is 1, 2, 3 units away, so 1, 2, 3 units away this way. So it's just a reflection. Now, if we have the line y equals 2, so remember the graphs, we've talked about this before, the graphs run the opposite direction of your axes. So this is going to be a horizontal line. So we're reflecting across this line this time. Okay, so we're still going to apply JAR. So we have 1, 4. Oops. So here's J. A is at 3, 5. R is at 2, 1. Okay. All right. So you still want to reflect across each line. So J is 1, 2 units away. So we would go 1, 2 units away. So here's the new J. A is 1, 2, 3 units away. So 1, 2, 3 units away. Now R is on the other side. So we go, it's 1 unit away, but we're going to cross on the other side. So R is going to be right here. Here's the new R. So here are the coordinates of our new triangle when it's reflected this way. All right. So if it's x equals -1, here is our line that we're going to reflect across. And don't forget, it always helps to draw your original points. So we have 1, 4, 3, 5, and 2, 1. Okay. So J is 2 units away, so we would go 2 units away. There's the new J. R is 1, 2, 3 units away, so we would go 1, 2, 3 units away. And A is 1, 2, 3, 4 units away, so we would go 1, 2, 3, 4 units away. Okay, now, if it's the line y equals x, remember y equals x is on your origin, and it goes through the diagonal of every point, just like this. Okay, it's going to be reflected across this. And basically, the easy way to do it is basically it means your x's and y's are going to flip-flop, okay? So if J, if we draw our original points, we've got 1, 4. A was at 3, 5. And R was at 2, 1. Okay, here was our original point. All right. If I flip-flop my points, and I'm going to write these out, my new J is 4, 1. Okay. So notice how it flip-flopped. So my new J is going to be 4, 1. My new A, and I guess I should have done that one in red. My new A is going to be 5, 3. So 5, 1, 2, 3. And my new R is going to be 1, 2. Okay. Okay, and so just imagine if we were to fold on that yellow line, that it would reflect on itself. Okay, but the easiest way to do it, instead of trying to draw out this one, the easiest way to do it is to flip-flop your numbers by hand and then draw it. Okay, now, on this example, they flip-flop and you change the signs, okay? Because your line is actually going the opposite direction, okay? So you're still going through the origin, but your line is going this way instead, okay? So what you want to do this way is you flip your X and Y and you change signs, okay? So if we put our original points on here, so we've got 2, 1, we've got 1, 4, and 3, 5. Okay, here is our original point, okay? So if we flip those points, it's going to be -4, -1, -5, -3, and -1, -2. All right, so let's see what those look like. So -4, -1, -5, 1, 2, 3, -3, and -1, -2. And you can see if we were to fold on that yellow line, those would be reflected. Okay, so we'll end on a few easy ones. X equals -2. So -2, if we go down to, over to -2, that's going to be the line that we reflect on. So our points, remember that we are reflecting 2, 1, 1, 4, and 3, 5. Okay. All right, so this point is 1, 2, 3 away, so we would go 1, 2, 3. 1, 2, 3, 4, 5. So 1, 2, 3, 4. We gotta go 1 unit off of the grid here. And 1, 2, 3, 4. So 1, 2, 3, 4. And if you want to pause and try these on your own, now would be a good time to do that. So y equals -1. So we go down -1, and we're going to be reflecting across this line. So if I draw my points here, sketch out our points. Okay, so this is 2 units away, 1, 2. This one's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And so we got, oops, I did 1 too many. So 1, 2, 3, 4, 5, 6. Yeah. 1, 2, 3, 4, 5. And we got to go 1 off the grid. So this one's going to be down here. And our last one, we have y equals 1. So we go up 1, it's going to be right here. So let's plot our original triangle. Okay, so this one's 1, 2, 3. So we go 1, 2, 3. Now this one is on the reflection line, so it's not going to go anywhere. It's going to stay right there. 1, 2, 3, 4. 1, 2, 3, and 4. And there we go. Okay, so rotations. We have rules for our rotations. And these are the rules for rotations. You need to memorize these. So for the rules, what happens, if it's 90 degrees clockwise, you switch X and Y, and you give the opposite sign to X. So if X is originally positive, you make it negative. If it's negative, you make it positive. If it's 90 degrees counterclockwise, you switch them, but then you make the sign for Y the opposite. So if Y is originally positive, you make it negative, and if it's originally negative, you make it positive. So 270 degrees clockwise and counterclockwise, notice that these two are the same. A 270 degree clockwise rotation and a 90 degrees counterclockwise rotation are the same. These two are also the same, because think about on the coordinate plane. If you are starting in this grid, and if you rotate 90 degrees clockwise, okay? 90 degrees clockwise is going to put you right here, okay? 270 degrees counterclockwise, so this is 90 degrees, 180 degrees, 270 degrees. It's going to put you in the exact same place. That's what makes them the same, okay? So that's why those rules are the same. And then 180 degrees, all you have to do is change the signs, because 180 degrees, well, think about 180 degrees. It's just going to go from here to here, okay? It's a straight line, okay? You're just on the opposite end of the spectrum, okay? And that's kind of where that saying comes from, all right? So 180 degrees is just on the other side of the line, okay? And that's why there's not two rules for those. So you don't flip-flop X and Y. All you do is change the sign, okay? So if we do the rules here for these, 90 degrees clockwise, we switch X and Y, change the sign of X. So in this example, what we're going to do is we're going to figure out what our new coordinates are going to be. We're just going to write down our new coordinates. So what I like to do is the first thing I like to do is I just like to go ahead and switch them. So for 90 degrees and 270 degrees, we first switched them. Oops. So if we switch them, and I'm just going to do this first, and we're not finished yet. This is just for the first step. Okay. Now, right now what we're doing is we're doing the 90 degree clockwise rotation. And notice the X is what we're changing the sign of. So what I need to do is I need to go back and I need to change the sign of my X's. I need to give it the opposite sign. So the 3 becomes positive. So I need to make it positive. The 4, I need to make it positive. And this 3, I need to go in and make negative. And so those are my final answers. Okay? All right. So now, if we go 90 degrees counterclockwise. So now I'm looking at this rule here. So I'm still going to switch them. So I'm doing -4, -3. 2, -4, -1, 3. And notice the Y is what the sign is changing. Okay? And I meant to highlight that. The Y is what I want to change the sign of. So that means the 4 becomes positive. This 2 I want to make negative. And the 1 is what I want to be positive. Okay? All right. On my next example here, we're doing 270 degrees clockwise. So they're still switching. So I would do -4, -3, 2, -4, -3, -1. Okay? And we're looking at, so 270 degrees clockwise, we're looking at this one right here. The Y is what's changing. Okay, the Y is what's changing. So I go back and I make this positive, this one negative, this one positive. Okay, I also know that, remember we said these two should have the same answers, and technically these two should have the same answers. So what I could do for D, as long as I know I've done A right, I could be able to copy A's answers. So that'd be 2, 4, and N is going to be -1, -3. Okay. Now, on example 3, it wants me to write a rule for the rotation. So we got to figure out what's happening. Now, if we compare these 2 points here, those are not good points to compare because they both have 2's in them. So I don't want to compare points A and A, okay? So I don't even want to really look at those, okay? B would be some good points to compare because I got 3, 6, and 6, 3. So I know that at least it's going to be, I know it's not a 180 rotation because the X and Y's have been switched. I know they've been switched, okay? So once they were switched, this one became negative. So I do know that they were switched, and I noticed that my front one changed signs, okay? So this one could be one of 2 answers. It was either a 270 clockwise rotation, or it was a 90 degrees counterclockwise rotation. So it was one of those. Okay. Example 4 or multiple choice. So if we look at the rotations that are happening, remember this one here, the one with the little, like here, this is the final image. So I'm going from here to here, okay? So if I look and see what's happened to my points, so for example, if I look at point F, if I get the coordinates of point F are 6, 3. And down here, they are 3, -6, okay? So I know that they switched, and I can see that this one became negative. So there's my answer right there, okay? And so this is basically how you do these types of problems. You just pick a point, and I would write out the coordinates and see what's going on there. Okay, so this one I went from here to here, okay? And if I look at, let's do Z, okay? Z is -5, 2, and this Z is 2, +5. So I know that they switched. And this time, when they switched, my 5, it changed signs, okay? So even though it was a negative and it became positive, it still changed signs. It was multiplied by a negative to become a positive. So you still do a negative times a negative to become a positive. So this is still what's happening there, okay? Okay, and last one of these, if we look at, let's just do point A. So we're going from here to here. If we look at point A is at 3, 7, and point A down here is at -3, -7. So notice they did not switch. It stayed X and Y. X still stayed at 3, but they just changed signs. So that would be my answer for that one. Okay. So our next example is if the point of rotation is not the origin, okay? So rotate the triangle 90 degrees counterclockwise around the point 2, 1. So let's say we're not around the origin. So these rules up here were only applied if it was around the origin. So let's say it's not the origin. So if we have our triangle, -4, -1, -3, 5, and -1, 3. Okay? And we're going to rotate it around the point 2, 1. Okay? So basically, we're rotating it around this circle here. Okay? So if we want to rotate it around this circle here, let's see if we can get a circle. All right. So basically what we're doing is I'm just like rotating that point around that circle. That's kind of what we're wanting to do. Okay. So I'm just going to move this off to the side here. Hopefully I can move it in a minute. We're not rotating it. So normally what we're doing is we're rotating it around the origin. We're rotating it right here. Okay. We're rotating it right here. All right. So what you want to do is you want to subtract the point of rotation off each vertex. So you always want to subtract. So we want to take for A, and we've got -4, -1. So we want to subtract the point. We want to subtract 2 and subtract 1. So if we do -4 minus 2, then that's going to give us -6, -2. Okay? And then for B, we got -3 and 5. So once again, we're going to subtract 2 and we're going to subtract 1. And that's going to give us -5 and 4. And for C, we've got -1 and 3. So we subtract 2, subtract 1. So that's going to give us -3 and 2. And then we rotate it as we would around the origin. So if we're going to do 90 degrees counterclockwise, we switch the X and Y, and we make the Y negative. So if I switch these, okay, so here's our step 2. So if I do A, that would be -2, -6, and then that's going to be positive. Then B is going to be 4, -5, and then I make my 4 negative. And then C is going to be 2, -3, and then I make that negative. So there's step 3. And then for step 3, I got to squeeze this in because I have my steps there. For step 3, I add the point of rotation back to each vertex point of the, and I think I left something off there, of the triangle, okay? So for my new point, so for A, I need to do 2 plus 2 and -6 plus 1, because this point right here is what I'm adding, okay? And for B, I would do -4 plus 2 and -5 plus 1. And for C, I would do -2 plus 2 and negative 3 plus 1. So my new A would be 4, negative 5. My new B would be negative 2, negative 4. My new C would be 0, negative 2. So if we plot these new points, I've got 4, negative 5. My new B would be negative 2, negative 4. And 0, negative 2. And we can see that if we move this circle, our points there would line up, and hopefully the center of that circle, you can kind of see the center of that circle is right there on that point of where that rotation would be. Okay? All right, so we'll practice a few more like these. Move my circle out of the way. Okay. Okay, so once again, if we do these points, if we've got the point 1, 1, let's do black, 3, 1, and 2, 4, and we want to rotate around the point negative 1, 0. So this is the point that we want to rotate about. Okay, so for our first step here, what we want to do is we want to subtract all those points. So for A, we want to do 1 minus negative 1 and 1 minus 0. For B, we want to do 3 minus negative 1. Oops. And 1 minus 0. And for C, we want to do 2 minus 1, negative 1, whoops, and 4 minus 0. So we'll get 2, 1, 4, 1, 3, 4. So there's step 1. Step 2 is we will rotate. So 270 degrees counterclockwise means that we flip them and we'll make the X part negative. So if we flip, we do 1, 2, and that one's negative. We do 1, 4, make that one negative, and 4, 3, and that one becomes negative. And then step 3, we add back. So we're going to do 1 plus negative 1, negative 2 plus 0. That's for point A. Then 1 plus negative 1, negative 4 plus 0. And then 4 plus negative 1 and negative 3 plus 0. So we'll get 0, negative 2 for A. For B, we'll get 0, negative 4. And for C, we will get 3, negative 3. So if we plot this, 0, negative 2, 0, negative 4, and 3, 1, 2, 3, negative 3. Okay. So if we were to put our circle there, of course it's a little bit smaller. You can see how it's rotated around that. Okay, last one, we've got our points plotted, and we're going to do it around the point -1, -1. So for step 1, what we want to do is, remember, you want to subtract those points. So for A, we've got 1 minus -1 and 1 minus -1. For B, we've got 4 minus -1 and 2 minus -1. And for C, we've got 3 minus -1 and 3 minus -1. Okay, so when we simplify that, remember the double negatives are going to turn positive, so we're going to get 2, 2. For B, that's going to be 5, 3. And for C, that's going to be a 4, 4. All right, step 2, 180 degrees. So that means all that's going to happen is our signs are going to change. So that's going to be -2, -2, -5, -3, -4, -4. And then step 3, remember, you add your point back to it. So -2 plus -1, -2 plus -1 for point A, -5 plus -1, -3 plus -1, and -4 plus -1, -4 plus -1. All right, so when we simplify this for A, we get -3, -3. For B, we get -6, -4. For C, we get -5, -5. So what that's going to look like, here's A. B is going to be over here. And C is going to be down here. And you can see it was rotated. You can see how they're kind of evenly spaced from that point.